NumPy is short for numerical Python and is a library designed for efficient scientific computation. It's built on top of the programming language C, which works at a lower level on our computer. To understand what this means for the speed of our code, see the link in the instructor notes. At the core of NumPy is its n-dimensional array object. This is just a multi-dimensional array that holds a group of elements that all have the same data type. In other words, it's like a grid that can take on many shapes and enforces every element in that grid to have the same type, whether that's string, float, boolean, or something else. Making arrays only able to hold one data type at a time helps NumPy make very quick computations with vector operations. These arrays, along with many useful functions in NumPy, can significantly optimize and simplify operations on data. Here's a simple example that demonstrates this. First, let's import NumPy with the standard alias for this library, np. This generates an array of 100 million floats between 0 and 1. Let's compare the time it takes plain Python versus NumPy to calculate the mean of this array. In standard Python, we do this by getting the sum of x and dividing that by the length of x. Pretty straightforward. Using the time package, we can check how long this line of code takes to run. Okay, that took about 9.3 seconds. Makes sense that it took a while with 100 million values. Now, let's see how long it takes NumPy. That was ridiculously faster. NumPy took only 0.092 seconds, while plain Python took 9.31. As you saw, NumPy can make a difference of orders of magnitude in computation time. Imagine how much this speeds up the process for more complex situations that require many more calculations. For example, let's say we're engineering a whole new feature or column in a dataset, which we compute by multiplying the values in two columns together and dividing that by the values in another for each row. Unlike NumPy, plain Python would require a massively long loop through all of the rows to compute the new value for each individual row. In many machine learning problems, you'll often find yourself using NumPy arrays in many situations. For instance, you might use a NumPy array to hold the pixel values of an image that'll be fed into a model for image classification. Later, we'll also learn about a popular data science package, Pandas, which is very useful for manipulating datasets. It's actually built on top of NumPy, which is why its computations are so fast. Now that you've learned a bit about the power of NumPy, let's get started.